Hello, so today we are doing this contest number 162. It has 4 problems, so let's get right into it. So the first problem is 1, 2, 5, 8 cells with odd values in a matrix, and the problem says we have n and m, which are the dimensions of a matrix initialized by zeros, and we have an array of indices, right, with the row and column index, and each pair we have here means that we need to increment the row at position Ri with 1 and the column at position I with 1, right? And we want to return the number of cells with odd values, right? So that's the gist of the problem. So the first solution that we can think of is just simulation, right? Because this problem is like the constraints are very small, so it's 50 at most and 50 for each row and column. The indices can go up to 100, but they are like capped at like n and m, so it's not very these are not very big numbers, so we can just simulate it and return the results. So the first most straightforward solution would be to just say let's just so the first most straightforward solution is just to go through so first let's create the matrix that we wanna set up. So we would have 0 values, so for the row portion, and then for the column portion, actually it's n here, and so these inside it's the columns, and then outside it's the rows. So the rows are n and the columns are m. Then we need to go through the indices, and after that we need to just increment for each thing. So for the values in row, right, so we need to go through the columns for the row, which is, let's just call these. So for the columns, and then it's for this row that we want to increment every value in there by 1. And then for the column portion, we need to go through the row and change each value in that column, right? So that would be I, and the column would be C, and we need to increment that by 1. And at the end, we could just return all those that have that are basically odd. So we can just do the sum, because in Python we can do something like this, where you could, if we do sum of true and false, it would give us the number of true values. So that would be let's give this as a list. So it would give us the number of truths. Let's add another one just to make sure this is correct. And you can see here, if I remove the false value, still have 3. If I remove the true value and maybe add false, I would have 2. So it counts the number of truths, right? So that's what I'm going to use here. And so for every cell, if it's odd, then this value will return true, right? And so I just do that for all the content of the matrix. And so it's like this. And that's pretty much it. In terms of time complexity, let's say for this solution, let's say L is the length of indices, right? So what we would have here is this would be O of L, because we are traversing these indices once, plus here we are traversing the entire matrix, so it's n by m, right? So this is the time complexity. And space complexity, we are using just one extra here to create the matrix, so it's O of n multiplied by m, right? So let's run that, submit. Okay, so that passes. Another way we could do this is instead of adding 1, we could use binary, because so here we add and then we find those that are odd, but if we we know that we will be adding just 1. So XORing 1 with 1, we would get 0. And XORing 1 with 0, we would get 1, right? So that means if we XOR 1 and then XOR with 1 again, we would get 1, because it's the number here is odd. And if we XOR 1 4 times here, we would get 0. So whenever it's even, the value of the XORs would be 0. Whenever it's odd, the number of adding ones would be odd, then we would get 1. And so we can use that instead of plus here and use XOR here. And then that way, what will happen is that at the end we will have either 1 or 0 in the cell value. We would have 1 if it's odd, and we would have 0 if it's even. And so we could just do the sum instead of doing anything else. And we can submit that. And that passes. The time complexity is still the same. It may be a little bit faster because we are not doing the check for odd here, and then we are not doing the plus. We are doing just XORing. So another different way we can solve this is, instead of going through here and before we were adding 1 like this, instead of doing that, we could do something slightly different, which is using Python's collection counter. So from collections, we could import counter, which just counts how many ones in one place. And so what we would do here is we would just have just get rid of this. So we'd have row and column, which just counts the the occurrences of these, like for each row and column, like how many times should we add 1 to a specific row, right? And so that would be just counting the number of row things in indices, right? And doing the same for the column. Maybe it would be good to show you what that will look like in an example, on an example here. So let's take maybe something that is a little bit so let's take these, let's for example take these as indices. So if we take these as indices, what would be the counter for the rows? So let's say we need to import first, of course, and so the counter for that would be, for row 0 we want to add it. You can see here row 0, it's just occurs 1 time. For row 1 it's also just 1 time. But if I, let's say, change my indices a little bit and say add 0 again, right, and maybe column 2, let's see what happens in that case. So now you can see that for the row at 0 we need to add 2 times. If I do that even more and add another, let's say 0, 3 for example, and maybe another for the first row, for the row at index 1, and for the column at index 1, like occurs 2 times. So if I do the counter again, you can see that for row 0 it's now occurring, we need to add 2 3 times, because it's here, and it's here. For the row 1 we need to add 2 times because it's here and here. And this we are doing only for the row. If we do the same counting for the columns, you could see is that, yeah, I need, for columns it should be the row ignored and we want the column. So you can see the first column happens 3 times, 1 2 3. So we need to add 1 to it 3 times. The second column just once, the third column just once, right? And so that's what we are doing here. After that we can just return the sum, right? Because right now we know for the for each row how many times we need to add 1 to it. So if that's plus for the same for each cell, let's say for cell at position 0, 1, we will need to add 1 3 times, and we need to add 1 3 times again for the column, right? So for each cell, we will need to add it's the number of ones that needs to be added to it coming from the row, and number of ones that needs to be added to it coming from the column, and check whether that's odd. So using that, and this is for I and j in so I in range of row, and for in range of n, and j in range of columns, the columns, which is m. And that would, same thing, count the number of trues, so it will count the number of odds. Okay, so that passes. In terms of time complexity, it's almost this, it's actually the same, right? Because so at least for the time complexity, we are going through the indices twice, so it's 2L. That's almost like 1L in terms of big O. It doesn't make a difference. And then for here, we are doing n by m, so this portion is still valid, so the time complexity is still the same. However, for the space complexity, we are no longer doing the entire matrix, so it's not n by m now, right? We are doing the row, which are of size indices, and column, which are of size indices. So now it's a lot better. It's a 2L space, which is just OVL space. Okay, so with this, after this, there is one more clever solution that we can look at, which is, so basically what we are going to do is, instead of using ones and twos to count how many times we need to add 1 for each row and column, what we are going to do is use true when we want to add 1 to a column or 1 to a row. That way, when we want to add 1 2 times, it becomes even, and that's false. So that's not even, that's not odd, so we don't need to count it. But as soon as we add another true, that becomes true because it became odd and we need to count it. So that's what we will be using here. And so we would initialize with false, and have column also initialize it with false, and go through the indices. And now, instead of adding 1, what we will be doing is just XORing with true, because that way, when it's odd, we would have false, when it's even, we would have true. And so that would mean that row at position R would just XOR with true with false, and for the first value 1, it would be just XORing false and true, which is 1, so and is odd, so it should be true. And that's what we would have. And then we would do the same thing for the column. And the next portion would be to count how many how many odd values we would have, right? So we need to count those. So what we are going to do is we are going to declare a variable to count the rows, and one to count the odd columns, and each would be initialized to 0. And here, count odd row would be, what we will do is, if a row R is true, which we said when it's true, that means it's odd because we added 1. And when it's, so 3 for example here is odd, it returns true. If we had any even number of trues, we will get false, because that's how XOR works. The same values give always false. An even number of the same values give always false. And so if it's true, that means we have an odd number, so we need to add 1. Otherwise, it's even. In that case, we need to subtract 1, because this counts the number of odds. If we just had an even one, that means there was an odd one like this, maybe with 3 trues, and then we added 1 true and it became even and it became false. So we need to subtract, so we do -1. And we do the same thing for count add column. If column at position C is true, that means we have an odd number. If it became even, that means now we have -1 to do. And that's, sorry, I think I'm making a mistake there. Not -1, it's actually just 0, because this is a new value, right? A new index, and so we should say 0, right? And that just means, in Python, that just means adding true, because that's what adding true does. If it's adding a boolean does. If it's true, it adds 1. If it's false, it adds 0. And so that would be like this. And then at the end, we want to return. So we know the number of odd rows, right? And so those, for each row, we need to add basically for each value in that row. And each value in that row, that's just the number of columns multiplied by the count odd row. Plus the number of, same thing for column. Each column, we need to add this number that is odd for each one of them, right? And each one of them is just the number of rows multiplied by count odd. The only problem becomes that there are some cells that are common in the count odd and count rows, where we would have 3 plus 3, which is odd. Let's say 3 added by the row and 3 added by the column, and both are odd. But because we are counting it here twice, the value is even, so we should not be adding that. So for these, we need to subtract them 2 times, because we added them 2 times. We add them 1 for this one and 1 for this one, and so we should subtract them 2 times. And the number of those that we have is just count row multiplied by count odd column. And that's pretty much it. This is similar to the inclusion-exclusion principle, where the number of elements is just the number of elements in the first set plus the number of elements in the second set minus the number of elements in the intersection. So it's called inclusion-exclusion principle. Yeah, basically the number of elements in 2 sets is the number of elements in 1 set plus those in a second set minus the number of elements in the intersection. And so if we submit this, there is a slight problem. Let me just make sure that it's not because of Yep, actually the problem is what I said earlier is was true. It's if it's odd, we need to add 1. If it's even, that means that one value was odd and just became even, so we need to subtract it. Yeah, and so let's run this again. It still fails. Oh, I'm replacing the value. I should be adding it. Yeah. Sorry about that. Okay, now it should work. Cool, now it passes. So this one is, in terms of time complexity, if again we take L as the length of indices, the time complexity is O of L for this loop here, but that's it. We are not doing any other loop, and this one is constant. So it's really a lot better in terms of time complexity. In terms of space complexity, here we are using only this extra array and this extra array, but we are using after that just these variables, so it's constant space there, but we have oven here plus ovm, so it's better than the oven multiplied by m that we had in an earlier solution. And so this one is by far the best one in terms of time and space complexity. Yeah, so that's it for this problem. Thanks for watching and see you next time. Bye.